Okay, we are back talking about the 2023 reasoning paper for maths for SATs. I can't believe that in the last video we only got up to question 12, but here we are. So let's crack straight into it. Question number 12, draw all lines of symmetry on this shape. So I'm just going to quickly do that for you. It's going to not be straight at all, although actually not too bad. Straight down there, use the dots. Please do use a ruler. I don't have a ruler. And it is across all the way there. You can go beyond the shape if you want to. Ideally, just on the shape would be great. I don't actually have any maths tools. Have I got a ruler right now? I could have used a ruler. There we go. I'm not sure if that would help me actually draw it. But as you can see, you could fold that shape that way. You could fold the shape vertically as well, but you couldn't fold it diagonally. If you fold it diagonally, those corners, those little triangle points would not line up. So you would get the mark if you did it like that, but please use a ruler on these kind of questions. Question 13, time for a bar model of sorts. It says 1/5 of a number is 22. What is the number? So you want to be drawing out a bar model because you could get yourself confused here. So I'm going to quickly draw a bar. It's not going to be brilliant. Do 1, 2, 3, 4. So I've now got 5 pieces. So I've got the number split into fifths. 1/5 is worth 22. So every single other fifth is going to be worth 22 as well. And then we go, you've got 5 lots of 20 is 100. 5 lots of 2 is 10. So the answer is 110. The reason I'll be writing out a bar model there is because some people are going to get confused and be like, what's 1/5 of 22? So you really got to ask yourself a question, okay, 1/5 of a number is 22. Can I draw that in a picture? And then can I answer the question based on that? Not just, oh, I can see 1/5, I can see 22, let's do 1/5 of 22. It's not always going to work like that. It would be a little bit too simple. Question 14, we are going to need one of the maths tools for this one. We are going to need a protractor. It says measure angle A. I will do a separate video on using a protractor, but let me give you some basic tips. Turn upside down. This central point here that I've got the pen on is called the origin, almost like a crosshair. That needs to be jammed right into the origin, the start of the angle. So you just go right into where that is, as best you can. That's about as close as I can get. Remember that an angle is just a measure of turn, how much something's turned. So imagine that first line, it opens all the way up. The amount it's turned is angle A. Now what you want to do is line up the baseline of your protractor with one of the lines. If I move it out of the way, you can see I've got a horizontal line. I've got the origin jammed into the middle of it, and it's lined up with the baseline. The final thing that people get wrong is they look at the protractor, they measure around how much it's turned. Obviously, this is the angle of turn all the way around here, and they read the first number they can see. Oh, there's 50 there. And they just write down 50 degrees. The way we get around that is, if we started and we've set this angle on 0, start reading from 0. So you could be on either one. You could be on either one of these rows of numbers, but the one we know to start on is we're always going to start on 0. So here we've got 0. The next bit we've got 10. So we're reading up that outer scale there, 20, 30 and onwards, 30, 40, 50, 60, 70, 80, 90, all the way up to 130 degrees. It's pretty much bang on 130 degrees. I'm happy with that. And also just check, we've got an angle that looks a bit like this if we had it the right way around. And we've got to think to ourselves, is it bigger than a right angle? Yes, it is. So it's going to be more than 90 degrees. So the quick check, more than 90. Put the origin right in the middle of the angle, line up one of the sides and start reading from 0. But I will do a separate video on that, but hopefully that will stick in your mind anyway. Still got a protractor, not needed for this one. Here are 4 fractions. Write the fractions in the correct place on the number line. Again, you want to log yourself into what we're doing. Okay, so we're on a number line. So what do we need to do? We need to calculate the jump. The best thing to do is calculate the jump on a number line. I've got 0 all the way up to 1. I'm going to see how many jumps I've got. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So everything is in twelfths. And I would be labeling that 1/12, 2/12, 3/12, 4/12, I would really be doing this in a test paper. It's going to set everything else up for me. 8/12, 9/12, 10/12, 11/12, and then 1. And now you can see what have we got? So here we've got something that's equivalent to 2/12, something that's equivalent to 3/12, something that's equivalent to 4/12, and something that's equivalent to 6/12. So we could convert these times 4, that would be 4/12, 1/3. So I can put 1/3 in there. It's the same as 4/12. 2/12, 1/6 is the same as 2/12, just double both of them, times 2 times 2. So 1/6 goes in there. I've got 2 more to get now. 1/2, 6/12 here, times 6, times 6, 6/12, 1/2, and that leaves me with 1/4 there, which we can see if we divided that by 3, If I clear off all of the other bits there, and maybe a bit of that line work down there, it's going to be a little bit more simple to see. But don't start jumping into trying to solve the question straight away. Log into the mode. Right, I've got a number line here, so I need to work out how much the jump is. Now when I've got them all in 12s, all I need to do is look at equivalent fractions. Then I can go back up to the answers and deal with it after that. Okay, one day last year, the rate of rainfall from 6:30 a.m. till 9 a.m. was 2 millimeters per hour. 2 m equals 1 hour. What was the total rainfall from 6:30 a.m. until 9 a.m.? So I'm just going to break this down as well. Because we've got a half an hour there, strangely, 6:30. 1 millimeter every 30 minutes. So I could count on 6:30 till 7 is a 30-minute block. 7 to 7:30, 7:30 to 8, 8 to 8:30, 8:30 till 9. I've got 5 30-minute blocks. Leave me with 5 millimeters, or 2.5 hours for each hour. I do a half an hour up to 7 o'clock, that's 1 millimeter. Then I've got 7 till 8 is 2, and 8 till 9 is 2. Still leaving me with 5 millimeters, whichever way you break it down. So it is a measurement of time on this one, but it's also asking you to just make that small change, that small adaptation from 2 millimeters per hour to 1 millimeter every 30 minutes. Next one. This is one where I think we're going to draw a picture for. The manager of a flower shop orders 4 boxes of red roses. 4 boxes. There are 50 roses in each. I would be writing this. I would be writing 50 on each. I'm not even worried about the maths right now. I'm just visualizing what we've got. The manager makes bunches with 6 roses in each bunch. 1, 2, 3, 4, 5, 6. And that's a bunch there. Okay, so I know what we're looking at. What is the greatest number of bunches that can be made? Well, firstly, we need to know how many flowers we've got. We've got 4 times 50. 4 lots of 50. We've got 200 of them. And now each bunch has 6. We're going to do a divide. Each bunch has 6. We have 200. Bus stop method. How many times does 6 go into 2? It doesn't. Move the 2. How many times does 6 go into 20? 3 times. How many have we got left over? 2. 3. And then we keep making extra places, but it's going to be 33.33333 and keep going on. Doesn't actually quite finish. So we can make 30, we can have 33 1/3 bunches, but we want to know the greatest number of bunches, complete bunches that we've got. So we can't have 1/3 of a bunch because that would only have 2 roses or 2 flowers in it. So we can only make 33 complete bunches. What most people will drop on this one is they'll put 33.3 or they'll put 33 1/3. But you've got to notice what's in bold there, the greatest number of bunches that can be made. And that is talking about complete bunches. So it's having that sense right at the end of the answer. I know you've done a multiplication. I know you've done a division as well. And there's a tendency to go, right, I'm going to pat myself on the back because I've done really well here. I've done a division. This is solid. And just dropping that answer straight in. But we've got to think to ourselves, okay, what was the question asking us? Number of basically complete bunches, 33. Next question. Cinema sells tickets at 3 different prices. 1/20th at price A, 3/5 at price B, the rest at price C. What fractions of the tickets are price C? Well, we know about fractions here. It doesn't matter about cinemas and tickets. It could be anything at all. But we've got 1/20th, and we're trying to compare it. to 3/5 here. We're working in two different denominators. This is not going to work. So we're going to convert this to make it into 20ths. We're going to always work towards the biggest denominator, because I can't divide this 20 by 4 because I wouldn't have a whole number there. I wouldn't have an integer as my numerator there. Lots of maths terminology, I know. But let's just convert it up. So times 4, and that leaves us with 12 20ths. So now we can have 12 20ths here. We now have 1 20th up there. Now we can deal with whatever it is the question's asking us to do. Just block that bit off. The rest of the tickets at price C, what fractions of the tickets are price C? Okay, so 1 20th, 12 20ths. So far we've got 13 20ths in others. And so the remainder that we've got over is 7 20ths of price C. 7 20ths. Going to do a really quick check. So I know that these two together make 13 20ths, A and B. I've got 7 20ths. The way I would just check whether I could simplify it is, can I halve both those numbers? Can I divide them both by 2? I can't do it with the 7. Also, can I divide both the numbers by the numerator? I can't divide both of those by 7. I'm just going to leave it there at 7 20ths. I can't simplify that anymore. We're doing well. This is a difficult paper. 2023 reasoning paper is difficult. It's very long. So write the missing number to make this division correct. 15,000 divided by a certain amount equals 75. Well, we can drop that into there. We can have 15,000 and we can divide it by 75. So it is a double-digit division, but you're not going to really need to write a toolkit. You could if you wanted to, 150 and then 225. But you could probably notice we're not going to need that. How many times does 75 go into 1? It doesn't. How many times does 75 go into 15? It doesn't. So we move the whole lot over to 150. How many times does 75 go into 150? 1, 2. And the rest is 0, 0. And the answer there is 200. Quick 2-second check. 15,000 split into 200 groups. Does 75 sound about right for that? Yeah, absolutely great. If we had a number bigger than 15,000, or we had a really, really small number like 4, we could quickly check it and we'd know whether we were right or not. So does it make sense in your mind? Yes, it does. I despise missing number problems. I really do. But here we are. Right, the two missing numbers to make this long multiplication correct. So this top calculation, you're going to do the 3 by 5. This is going to relate to this top line here. The 3 multiplied by everything is going to relate to this top line. So we can work it through. 3 times 5 is 15. So I'd put that there. 3 times 3 is 9, add the 1 is 10. 3 times 2 is 6, add the 1 is 7. 3 times something is 9. Okay, 3. Not too much of a problem. Next one, multiplying everything by 50. So we put our little magic 0 in there. Good. And then something times by 5 is a 5. So you could consider a 1 in there, but if we did put a 1 in there, it's not going to work carrying on, because then we've got 1 times 3. I'd be expecting 3 there, and I don't have it. So it's got to be something we're multiplying 5 by something, it's going to end in a 5. So it needs to be like a 1, because it's going to end in a 5. 3 times 5, we could try that, because that would end in 15. If we put 3 in there for now, 3 times 5, 15. 3 times 3 is 6, add the 1 is 7. So that's good, so that works for me. 3 times 2 is 6, but I don't have a 6 there. So that can't work. So next number I'm going up to 5. I'm going to put 5 in here, trial and error. 5 times 5, 25. 5 times 3, 15. Add the 2, 17. Okay, works so far. 5 times 2, 10. Add the 1, 11. Okay, now we're on. Then 5 times 3, using our first answer, 15 with the 1, 16. That is tricky for 2 marks, because you have to do trial and error really to run it through a few times. Missing box problems, always trouble. Question 21, we're getting there. The height of the tallest person in history is 8 feet 11 inches. Conversion table, 1 foot equals 30 centimeters. 1 inch equals 2.5. You know you're going to need both of them. Use this conversion table to calculate the height of the tallest person in centimeters. Okay, he's 8 feet 11 inches. So 8 feet equals 30 centimeters times by 8 of them. 0, 3 times 8, 240. Okay, so 240 centimeters, that's how much of just the whole feet he was. Then 11 inches, we're going to do 11 inches times by 2.5. And I'll do 11 times 2 is 22, and then a half is 5.5. So I'll just do that in my head really. I'll do 11 times 2 equals 22, and then 11 times by 0.5 equals 5.5, making 27.5, and then add that on to the 240 that we've got, 0 if you want, 5, 7, 6, 267.5 centimeters. So fussy, but just two multiplications put together on that one. Question 22. Here is a regular hexagon. The area of the large shaded triangle, that's here, L, is double the area of the small shaded triangle there. What fraction of the whole hexagon is the shaded area? Right, well, we've got to have a little look, see how we can break this up. So we could break up the hexagon here. There's some big triangles in there, aren't there? And so there's 6 big triangles. 1, 2, 3, 4, 5, 6. But that's not really going to help us because we have half a triangle. So if we split everything again so that we can account for the fact that we've got half triangles, and everything's going to be in twelfths. We know hexagon's a 6-sided shape as well, so it makes sense that we split it into 6 to start with. I really do appreciate that's awful drawing. But now we've got 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 pieces. So we're into twelfths. How many of them are shaded? 1, 2, 3, 3/12. What fraction of the whole hexagon is a shaded area? 3/12. Can we do anything with that? Yes, we could say it was 1/4 because divide by 3 and divide by 3. Okay, or you could just leave it as 3/12 really. A small box contains 650 grams of cereal. A large box contains 20% more cereal. One portion of cereal is 40 grams. Whoa, it's complicated, isn't it? So we've got the small box. We need to work out how much is in a large box first. Don't worry about this one portion. Don't worry about the portion. Block that off. 20% more. Well, with a percentage, I'm always going to find 10% first and double it. So 10% of 650 equals 65 grams. So 20%, let's double that, which makes 130 grams. So then I need to draw my large box. You can see the small box actually is 650, and then we can add on 130, giving us 780 grams. If you wanted to do a very quick addition, so you didn't drop a mark halfway through for no need, just do it. It doesn't take a second. 0, 8, 7, and then you can drop that on there. Now we need to work out how many portions there are. Well, each portion is 40. We have 780. What can we do with this? We might need to do a toolkit. 40, 80, 120, 160, 200. Let's just see what we need. Okay, how many times does 40 fit into 7? It doesn't. How many times does 40 fit into 78? Once, but not twice. Once gets us to 40, we've got to get up to 78, and we're 38 away, aren't we? We're 38 away because we've got to 40, and we've got to add another 38, gets us up to 78. So now we've got 380. So our toolkit needs to be extended dramatically to 40, 280, 320, 40, 80, 100, 160, 200, 240, 280, 320, sorry for my terrible writing, 360, and the next one to be 400. The reason I was checking is I was expecting it to be a nice rounded number, but it's not going to be. I should have noticed that it asked for full portions. So how many have we got? We're looking for 380. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 with a remainder of 20. We don't need to do anything with that remainder though, because if we look here, we have 19 full portions, and we have a bit of a portion, but the question asks for full portions in a large box. Well, we've done the large box because we're up to 780. We got to 19. We had a bit left over, but it's not enough for a full portion. So that is where we're going to leave it for the moment. I know that we flew through that. We do have a few more questions left. Shall we finish it? Let's finish it. Go on. Let's finish it. We've got 3 more questions. Push on. No point doing a whole other video for 3 questions. 1,200 pupils were asked the question, how important is it to have a break when using a screen? Chart shows the results. So 1,200 equals 100% of the people. Not important said 12. 41% said quite important. And a number of people said very important. Well, if we add the numbers that we've got, 53%, we're left with 47 to make up the 100 there, 47%. Now we've got to find 47% of 1,200. A little bit tricky. 10% equals 120 times by 4. We give 40%. And that would get up to 480. 5% would be 60 because we just halve what we had before. And then 1% would be 12 because we do 10% of what we had at the top here. 10% is that, 1% is 12. And I think we've got everything we need. So 40, add the 5% makes 540. Add a couple of 1% on there. That's 24. 2% is 24. Makes 564 pupils. 564 pupils. Checking that in my mind, 1,200. We're looking for something that's less than half of that. Yeah, that's about right, 564. Good job. There are 25 sheets of paper in a small pack. There are 500 sheets in a large pack. How many small packs make one large pack? Okay, well, it's a division. We have a pack of 25. We have a large pack of 500. Should be relatively simple. Let's have a look. How many times does 25 go into 5? It doesn't. Now we've got how many times does 25 go into 50? Twice and 0. 20 times it goes in. The mass of the paper in a large pack is 2.4 kilograms. What is the mass of one sheet of paper in grams? Man, okay. So 2.4 kilograms. Kilo means 1,000. So 2.4 times 1,000, 2,400 grams. Just need to know that kilo equals 1,000. Write that at the side of your page if you need to. So the whole lot is 2,400. And we need to work out the mass of one sheet of paper in grams. So we need to divide that by the amount of sheets there are. So 500 sheets in a large pack. And we need to divide that 2,400. Okay, how many times is 500? 0, 0, 0, and then we're straight up to 2,400 like that. So we've got 500, 1,000, 1,500, 2,000, 2,500. Should be able to see it goes in 1, 2, 3, 4 times. Going to need to do a little remainder here, a big remainder here, of goes in 4 times with 400. And we should be able to see that it's going to be 4,000. How many times does 500 fit into 4,000? Fits in 8. So every 2 you get 1,000. So 4.8 grams is our final answer there. God, that's fussy as well. This is a hugely complicated reasoning paper. We're almost done. This is the last one. This formula is used to estimate the mass in kilograms of young children. Mass equals 2 times age in years plus 5. Stefan's sister is 4 years of age. Use this formula to estimate her mass. We do the brackets first. 4 add 5 is 9. Times by 2 is 18. Just go for Bob mass. Plug that number in there. You got a 4. Plug that in. 18 kilograms. The mass of Megan's brother is 16 kilograms. So the total is 16. Use the formula to estimate his age. 2 times A plus 5. So we need something in there. Times by 2 makes 16. So I would just I wouldn't try and break all the brackets up and everything and get too deep into the algebra. Plug some numbers in. So if I tried 1 in there, 1 add 5 is 6. Times by 2 is 12. So we're getting there. We're getting closer. What about if I put 2 in there? 2 add 5 is 7. Times by 2 is 14. Okay, we're on the right track. 3 in there. 3 add 5 is 8, times 2 is 16. So we've got to that there. And it makes sense as well if we think about it. Stefan's sister is 4 and she's 18 kilograms. So we're expecting somebody less than the age of 4, aren't we? Because if Megan's brother is 16 kilos, we're using the formula, he should be less than 4. So it isn't like in most trial and error situations where you have to try loads and loads and loads. We only have to do 3. That's the end of the reasoning paper. Well done if you've made it this far. That was a slog. It was really difficult. I've given my main tips here. Sorry, smacking the mic. Draw pictures to help you understand ideas. We did that in lots of them, specifically the roses one. If I can find the question with the roses. Well, we've drawn everything, but we've got boxes of roses there. That's important. It just helps to get information down on the page and you don't have to hold it in your working memory so much. It can really help. Log in to what the question is asking you. When you get to any question, right, what topic is this? What do I know I need to do? And I'm trying to think of a good example of that, and that would be the number line. As soon as you get to the number line, regardless of what the question is actually saying, okay, with the number line, I need to calculate the jump. So I need to work out what denominator we've been split into, draw out the number line first, and then I can come back to answer the question. So log yourself into what the topic is first, what do I know about it, and then come back to the numbers. And my personal favourite, don't fall in love with a question. If there's something that's really tricky, I'm trying to find this. There we go. This whole work of percentages here was worth 1 mark. That's a lot. That's a lot of going on. But if you had an earlier question, I'll go back to one of the other ones. Maybe you were really struggling with your protractor, you just couldn't get it going, you couldn't line it up, you didn't know which way to go. Okay, move on because it's worth 1 mark. You don't want to be spending 10 minutes on one question that's worth 1 mark. Don't fall in love with the question, just move on. And by the time you've come back to it, maybe something just clicked in your brain where you're like, oh yeah, I remember what I need to do. I just need to flip that protractor over and I'll get it. So don't fall in love with the question, especially if it's a 1 marker. Just move on with your life. Hopefully that's helped. So you have to look at part 1 of this video to look at the starter questions. This is part 2. If I have the stamina and endurance, I will do another reasoning paper, but please let me know what would help you. If you want me to go through a particular paper, you did a past paper, say 2018 SATs, and you want me to go through that one, whatever, just let me know. Share it with somebody who struggles with reasoning. That's like everyone. And subscribe as well. Until next time, peace.